Well, you reached the top of the countdown now, and the number one event, you can tell it's going to be a winter event, and occurred in Casper. That was a record snow you had back in the middle of March between the 13th and the 14th. Now I'll take a look at a few parameters here. Number one, SKU-T diagrams. You know I like those. Now two things I want you to notice on this. Number one, you can see the two lines here. One is moisture, that's over here on the left, and temperature, that's over here on the right. Notice how they're pretty close to each other all the way up? That means the atmosphere is fairly saturated, so a lot of moisture in the atmosphere to help produce that snow. And the other thing I want you to look at, look over here to the right. Look at the lower two wind barbs here. These are wind barbs here. Notice how the lowest one's coming is pointing this way, so it's north. Then you have northeast a little bit above that, up to about 5,000 feet or so. So west to the south and southeast of Casper Mountain. So when it hits that mountain, they can't go into the ground, so it gets lifted up, and it's what's called upslope. And the air cools as it rises, and cool air can't hold as much moisture as warm air, so it forms clouds and it forms precipitation, in this case snow, and a lot of it. This is the surface map for the morning of the 14th when the really heavy snow occurred in Casper. Here's the surface low that's developing just to the east of the Rockies, to the east of Denver here. This is a very favorable position for heavy snow across portions of central Wyoming. The flow around the system is counterclockwise, and you see these lines of equal pressure here. It comes up here. Now when you get that flow, you get an east-northeast flow here. So it helps to bring a lot of moisture into the area. Notice how packed these lines are here. These are called isobars, lines of equal pressure. Now the winds were too bad in Casper, but if you probably remember from the news, you went further southeast down towards Cheyenne, there was a really bad storm down in here. Some places in here got 3 feet of snow along with hurricane force winds, and they were shut down for 3, 4, 5 days in a lot of these areas. I'll be right back. Let's take a look at the satellite next. Here's the satellite imagery I was talking about. This is water vapor imagery showing where the moisture is coming from. I apologize I couldn't get anything further east, the only archived image I could find. But you can see this is actually coming in all the way from the Gulf of Mexico, just located right about over in this area, coming all the way up through the plain states up toward Wyoming, then wrapping all the way around back into the area. So a very deep moisture feed coming in, a lot of moisture that help produce a lot of snow. Now we'll take a look at the higher level up in the jet stream. Okay, we're back. One more thing we want to take a look at. We'll go all the way up in the atmosphere now. This is the jet stream level. You can see a very deep trough carved out across. You can see the jet stream going all the way down into Mexico pretty much. Then coming all the way back up here to around Wyoming and then coming back up here. Very deep trough here. So a lot of cold air aloft coming in here. But the thing I want you to really notice, I know you can't see this very clearly, but look over in here. You see all these lines? These are height lines. Lines of equal height. It's a technical definition. I won't get into it. But as they come in here, notice how when they get to Wyoming, they start spreading out like this. That's called divergence, upper level divergence. Now, this is also favorable if you want a lot of snow. Now think about it. You have air coming in here, and the weather is just really, when it comes down to it, the atmosphere trying to equal itself out. Now, when the air's rise, this promotes rising motions, it's diverging, and air has to rise up to replace it because it can't go into the ground. So it rises, it cools off, you have all that moisture in there, as you saw from the satellite picture, and it produces snow across the area. And these are the odds when that really heavy snow came in. It started right around 6 o'clock. I was working the midnight shift that night. It was just started snowing really hard at about 6 o'clock, but you had heavy snow pretty much for about 7 hours or so. That's visibility of a quarter mile or less before it finally let up as we head toward 3 or 4 o'clock. And there was some very heavy snowfall rates. How much? Between just 6 a.m. and noon, 15 inches of snow. That's 2.5 inches an hour for 6 hours, and that causes a lot of travel problems, obviously. Traffic around Casper pretty much came to a halt at that point. And there's a record snow for a lot of things. As you can see, biggest snowstorms of all time are ranked number 3, just behind the storms in 73 and 82. So the biggest storm in almost 40 years. That's very impressive there. And the all-time snowiest days, that ranks number 2, only behind the storm from, again, right before Christmas, 1982. That's kind of the benchmark storm in Casper. So as you look at the overall facts across the storm, biggest March snowstorm in station history, 3rd biggest of all time. There are widespread reports of 2 feet of snow around Casper, some places probably pushing 3 feet as well. And 15 inches of snow fell between 6 a.m. and noon on March 14th at the Casper airport. And obviously numerous roads were closed for several days around Casper, but especially to the southeast of the area. They actually got it worse than Casper there. Some roads down there shut down for 4 or 5 days. I know that people at the Weather Service office down in Cheyenne actually were stuck there for 4 or 5 days, and we had to back them up for a couple of days because they were so tired they had to go home and nobody else could go to the office. Well, that's our countdown of the top weather events of the 2021. Hope you enjoyed it. Have a happy new year, everyone.